So today's 9/6. Okay, so we are given a function which is x plus 1 divided by 3x minus 2. And we're given a point which is 1 plus h. And later on, we have a point t, x plus h. And the question is asking us to determine you can see, this is not what I meant. I meant this, so you can see better. Okay, perfect. So we're asked to determine, first I would like to just look at the background. Let's suppose we have a function, and this is the function f. And let's say on this graph, this is not the graph of this function. I just need a graph to explain what I'm doing. So on this graph, let's say we have a point, which is a point Q. And this point has coordinates, so disregard this for a moment. So this point has coordinates x and obviously f of x. So that's our Q, x f of x. Somewhere on the graph of this same function, let's say I have a point P. And this point P is very close. In my graph, it appears to be very far away from Q. But I'm going to say that it's very close. And the distance between the x of Q and the x of P is a tiny h. H is a tiny number or value, small. What is the x coordinate of P? Yes?
X plus h.
Of course. So if the x coordinate of P is is x plus h, what is its y coordinate of the same point P? Say it again. So P has x coordinate x plus h. What will be the y coordinate?
F of x.
Thank you. Okay. Now the next step is I will draw the secant line between Q and P. PQ or QP, doesn't matter. Can anyone tell us how to determine or what to write for the slope of the secant line QP? Please dictate. I have 2 points. I can determine the slope of the line passing through them. I don't have any difficulties with that. This is not even calculus, right? So what should I write?
1, 2, 1, 12.
Correct. Okay. So for this scenario, what do I write? You're right. You're perfectly correct.
F of x minus f of x plus h.
So normally we read from left to right, right? So this is my point 2, and this is my point 1.
F of x plus h minus f of.
Specifically, although you're right, I can put P on the other side. It's not a problem. Divided by
X plus h minus h.
Are we all in agreement with this? Do we understand what we're doing? Any questions on this step? Okay, perfect. So obviously these two go away because x minus x is 0. So then the slope of the secant line is f of x plus h minus f of x divided by h. Is there something from pre-calculus that we know about this expression?
It's a difference quotient.
Thank you very much. Difference quotient. This is the difference quotient for any function. Okay, so stay with me for a second, and here's my next question. This is the definition of the slope of the secant PQ. What happens now? What do you think it will happen if h gets closer and closer to 0? Don't say anything just yet. Allow me to show you what happens on the graph. So if h gets closer and closer to 0, what happens to p? Gets closer and closer and closer to q. So p getting closer and closer to q, so for example, if p is here, then the secant line will be this. At some point I won't be able to show because I'm getting too close. If p is here, this will be the secant line. If p is here, then this will be the secant line. And as h approaches 0, notice that I did not put the equal symbol, and this is very important. So this is approaches. As h approaches 0, and I have to write in parentheses, and I will write it several times already throughout the semester. H does not equal 0. This is very clear. I cannot replace in this expression h by 0. So as h approaches 0, what happens to the slope of the secant line QP? Notice that I did not use the equal symbol. What will this become? The slope of the tangent line at Q. Absolutely. So as P gets closer and closer to Q, the secant line becomes, or gets closer and closer to the tangent line at Q. And we do have a notation, which we hopefully will talk about it today. But you don't have to write it right this moment. So instead of saying all this piece and this piece, both will be condensed into a very simple, I shouldn't say simple, into a very well thought notation. So it will be that the limit as h approaches 0 of the slope of the secant line QP will be the slope of the tangent line at Q. Instead of writing these two, we will write this. This is what is called the limit operator. This is the limit operator. Okay, so this is the idea behind the way we determine the slope of the tangent line when we only have one point, actually. We only have one point. So the concept of the limit comes into play. But let's come back to our function now. So we have f of x, which is, x plus 1 divided by 3x minus 2. And we're interested in this point, q, when x is 1. 1 plus 1 is 2, divided by 3 times 1 is 3, 3 minus 2 is 1. So we are looking at the point 1 comma 2. I want to find a way to determine, so find, I would say better, approximate the slope of the tangent line at Q. Okay, I know how to determine the slope of a secant line. I find another point, I determine the slope of the line PQ, in this case, PQ, or whatever I denote the second point by, and I will be able to find, I can create another point. I can say, let's say when Q, second point P, when X is 5. I plug it in, I have 2 points, they belong to the graph, and I can find the slope of the secant line. That's not a big deal. But now the question is, how do I approximate the slope of the tangent line at Q? Okay. So this is my Q now, which is 1, 2. This is my P now, which I can calculate or determine in 2 different ways. I'm going to say this is 1 plus a little bit. I'm mimicking the previous example in which this was X and this was f of X. But now it's 1 and 2. Now my P is 1 plus a little bit, because this is the a little bit we are talking about. Can anyone give us the y coordinate of P? So I only have to plug in, instead of X, I have to plug in 1 plus H to determine the y coordinate. As I plugged in 1 here to get the y coordinate, which was 2. In order to find this y coordinate, I have to plug in 1 plus H. 1 plus H plus 1 is H plus 2 over 3 times 1 plus H. Let me write it. Maybe that's not clear enough. So if I have the function f of x equals x plus 1 over 3x minus 2, f of 1 is 1 plus 1, which is 2. 3 minus 2 is 1. If I want to find f of x, I have 1. 1 plus h. What do I have to do? 1 plus h plus 1. 1 plus h plus 1 over 3 multiplied by 1 plus h minus 2. Is this clear? I'm replacing x by 1 plus h. Are you okay with that? Everyone, please. Okay, thank you. So then this becomes h plus 2. I have to distribute here. 3 plus 3h minus 2. So then the top is h plus 2, and the bottom is 3h plus 1. And that is my y coordinate. Do we all understand how we got the simplified form of f of x plus h, 1 plus h? I'm thinking of the last option. Okay, so then, again, I will draw the secant line. I will determine the slope of PQ. Nothing different from before, everything the same. Can anyone dictate the slope of PQ?
H plus 2 over h plus 1 minus 1.
So it's h plus 2 over 3h plus 1 minus.
2, sorry.
Very good, excellent. Over.
Plus h minus 1.
Excellent. Thank you. Perfect. Okay. So then the denominator again is h. What about the numerator? How do I perform these operations? What do I have to do? That's why we did a similar problem in the readiness quiz, to refresh your memory. How do I add two fractions that do not have the same denominator? Very good, excellent. Can anyone give us the least common denominator?
3h plus 1.
Of course, it's the only one. Very good. So then the only adjustment needed here is because the denominator of 2 is 1. what will be the adjustment up there?
3h plus 3.
Excellent. Plus 1. 3h plus 1. And now, can anyone dictate the numerator of this fraction?
H plus 2.
I have to have h plus 2. Now I reached negative 2, right? That's okay. That's okay. I want everyone to participate. It's okay if you're wrong. So then minus 6h. And then I have to multiply negative 2 by 3h and negative 2 by 1. So minus 2. Did I lose anyone? Are you with me? Everything is okay? Please ask. Please. Are you okay? Yes? Okay. So the next step would be to, of course, combine like terms at the top, and h minus 6h is negative 5h divided by 3h plus 1. The denominator is h over 1. I'm at the point in which I can flip. So I divide the top fraction, which is negative 5h over 3h plus 1, and then I flip the denominator. What follows now? What is, it's not, I know what you mean. You just want to say, you simplify, please write 1 in order not to get confused and eventually put 0. So in order to determine an approximation or approximate the slope of the tangent line at Q, we created another point very close to Q. We found the slope of the secant line. We simplify the slope of the secant line. This is the slope of the secant line. And what will I say now? Because I really want to determine, and I'm coming back to my graph, I really want to determine the slope of the line that is tangent at this point. What will I do with h at this point? Make it approach
0.
Yes, let's make it approach 0. So when h approaches 0, can anyone tell us what this expression will approach? Excellent. What is your best estimate for the slope of the tangent line at Q? Negative 5. Negative 5. That's how we determine, but of course we're going to put that sophisticated, interesting limit operator in there, and we are not going to write this again. Any questions on this? Better? Perfect. Okay, so now this was the slope of the tangent line at Q. Now I want the other point. And then we can move on. So now I want the same function, which is x plus 1 divided by 3x minus 2. But our point is x plus h, comma, f of x plus h. X plus h plus 1 over 3x plus 3h minus 2. That will be our second point. And Q is x, comma, f of x. So one more time, here's our scenario to make it very clear. So this is our Q, and this is our T. Our Q has coordinates x, comma, x plus 1 over 3x minus 2. So this is our x, and this is our f of x. So this is our x plus h. This is our h. And of course, this must be f of x plus h. which is this. Again, I want to determine, so as you see, there are no x values here. So this is the most general situation. Again, I'm drawing the secant line cube t this time. And again, I'm asked to find the slope of the tangent line at Q. So please dictate, how do I start? What do I need to do? Because now this is the fourth time we're doing, I think the fourth or the third. Okay, so please tell me, what will you do first? And then we're going to look at the problem. Any problem you have in mind. How do I start? I have to find the excellent. Can anyone say anything?
It's going to be x plus h plus 1 over 3x plus 3 minus 2 minus x plus 1 over 3x plus 2.
Very good. And now we know what the denominator will have to be, which is good. Very good. Perfect. It's all the same thing. It's all the difference quotient. It just depends on how I denote the points. Okay, I'm ready. So the least common denominator is the adjustments are 3x minus 2 and 3x plus 3h minus 2. So then the top, can anyone dictate? Any questions? Please ask. Any questions? Any questions? Is it clear what we are doing? Please ask. You have any questions? Anyone? Okay, so then I have to multiply 3x by x, 3x by h, 3x by 1, negative 2 times x, negative 2 times h, and negative 2 times 1. This is only this product. Now I have to perform this, changing all signs because of the negative symbol in front. So x times 3x with minus in front, x times 3h, x times negative 2, negative 1 times 3x, negative 1 times 3h, and negative 1 times negative 2. Sorry, I ran out of room. What has to happen before we even look at such an expression at the top? What has to happen at the top? Correct. But at the end of the day, before I even look, I know one thing that has to happen at the top. What is that? Because in all these situations, what happened? So let's go back for a second. What happened at the very end? Really? It has to go away. That's the key. This one, I may still have h in the problem, but this one must go away. If this one doesn't go away, something is wrong. So in all our situations, I didn't have h here. No. In all situations, this h has to go away. So then, at the very top, all terms that do not have h must go away. so that I can eventually pull out an h. That will simplify with this. Let me say that one more time. Up here at the top, all terms that do not have h must go away, must simplify, must cancel out. And the remaining terms will have, from the remaining terms, we will have to pull out an h, because this must go away. And it has to go away with something from the top. So I see the positive 3x squared with a negative 3x squared. I see the negative 3xh. Even terms with h may go away, but definitely those without h must go away. The positive 3x with a negative 3x, the negative 2x with a positive 2x, the positive 2 with a negative 2. So all terms without h went away, and some of the terms with h went away. Okay, so then what is left at the top? Negative 5h, negative in front, 5h, divided by 3x minus 2, 3x plus 3h minus 2, and multiplied by 1 over h. What will happen next? So I don't know if I did not write it because I want to refer back to it. So I just want to make sure that you understand that this is the slope of the tangent line at Q. Just making sure I said it, but I didn't write it because I want to show you something here. Okay, so obviously h with h will go away. What happens next? Well, that's the slope of the secant line, right? So this equals, I'm going to write it one more time, the slope of the secant line QT equals negative 5 divided by 3x minus 2, 3x plus 3h minus 2. And that's my page 4. I have to number my pages because just in case if I drop them somewhere, then at least I know before I scan them, and after that it's okay. Okay, so I found the slope of the secant line QT. I was only given one point. I just invented another one close to the original point, and now I have this. So I'm asked now to find the slope of the tangent line at Q, and I know that that will come from here as long as h approaches 0. So what is the slope of the tangent line at Q for this particular function? What do you think?
Can you read the equation?
Negative 5, 3x minus 2, 3x plus 3h minus 2.
Plus h.
3x plus 3h minus 2.
3x plus 3h minus 2.
Correct. So what would be the slope of the tangent line at Q? Just give it a shot.
3x minus 2 squared.
But this is in the denominator. I cannot start with that. You want to start with the denominator? Okay.
Oh yeah. Yeah. So it would be, and then the 5 on top, right?
Okay.
So that's
What happened to this?
oh yeah, negative 5.
Very good. So as h approaches 0, this term must go away. Perfect. 3x minus 2 times 3x minus 2 will be 3x minus 2 squared. Negative stays. Yeah, we cannot remove any of this. Negative and 5. And it's always the same procedure.
So that's the
That's a
general rule, right?
right.
For
Exactly. So this is the slope of the tangent line at a particular point, and that point was when x was 1. Specifically, for x equals 1. What will happen if I make here x equals 1? what will I get? Let's make in here x equals 1 for the particular point. What will I get? Of course. Because this is nothing else but the slope of the tangent line to f of x, which is x plus 1 over 3x minus 2, at any point where, of course, the function is differentiable, but we don't know that yet. Okay? So there is an if here. But everywhere where the function is defined and it has a derivative, which I cannot speak of right now, we will do that in this chapter, then the function will have a tangent, and it will have a tangent with one unique slope, and that will be given by this expression. If you say now, what about the point q, let's say 5 comma, I have to determine 5 plus 1 is 6, 15 minus 2, 13. What about telling me what is the slope of the tangent line at this new q? I'm going to call it q1 to differentiate it from the previous q. What will that be? Can anyone dictate? Don't calculate it, just dictate it, and then I will write it, and then we'll calculate it.
It's the same.
If the point is different, or no. So if I have this, the slope of the tangent line is positive. If I have this point, the slope of the tangent line is 0. If I have this point, the slope of the tangent line is negative. So since this expression gives me the slope of the tangent line to the graph of f of x at any point, now I created a point with x equals 5 and y equals 6 over 13. What will be the slope of the tangent line at that point? How do I determine it? Can anyone say? How do I determine that? Exactly. Exactly. Exactly what I did with 1 to get negative 5. Right? When I had x a minute ago, I had x equals 1. Right? For x equals 1, I plugged it in and I got negative 5. Now I have a different point. Since this is the formula that gives us the slope of the tangent line at any point, tangent line to the graph of this at any point, then I can plug in 5. So I will have negative 5 divided by 15 minus 2, right? Which is 13 squared, 169. This is the slope of the tangent line to the graph of f of x at the point q1. Let's make one up, give me another ordered pair, so we can determine the equation of the line, of the tangent line to the graph of f of x at q2. Okay, so negative 5. Negative 5 plus 1 is negative 4. Negative 5, negative 15, negative 17, so 4 over 17. So can anyone now give us the slope of the tangent line to the graph of f of x at q2? How much is that? Negative 5 at the top, and the bottom is negative 17 squared, 289. This is it. And I can continue forever. Any question? Yes, please.
When we were first just plugging in x in general to find the 5 over 3x minus 2 squared equation, can you go back to where you found t's y coordinate?
Yes. I said Q is a generic point. It must, if it's on the graph, it must have an x, and it must have the y coordinate, which must be f of x. Then I said T is a point very, very, very close. But if I show it very, very close, I cannot explain. So H is very small. So since the point is also on the graph of the function, it will have x coordinate, whatever I wanted it to have, and I wanted x plus a little bit. And obviously the y coordinate has to be, I have to plug this x value into the function, and that's how I get this.
Okay.
I mean, for any x coordinate, I have to plug it in to get the y coordinate. And if this is my x coordinate, then I plug it in and I get this.
Okay.
So I replaced x by x plus h, and I replaced x by x plus h, but I have to distribute 3 to both.
Okay. Thank you.
And with using this procedure, I can always determine the slope of the generic slope of the tangent line to the graph of the function everywhere the function exists, and the function must have a derivative, which these are the conditions. But we don't know that second condition yet.
What if we don't know the function of y?
If you don't know,
And so like we were given f of x equals x plus 1 over 3x minus 2. What if we weren't given that equation?
then you will not be able to determine so they are connected. If I don't have the function, I cannot determine the generic expression, which is a function itself, in itself. I cannot determine it corresponding to the function. So they go together, please.
On that same note,
Yes.
We have essentially 2 points, Q and T. If you're only given one or the other, would we be able to?
It doesn't matter.
Doesn't matter.
So whatever you are given, you can always create the second one.
Okay.
So now I would like to answer your question. Whatever that question was, can you remind me which one you want to pick? There was a question that you had on the homework. I don't remember which one you want. Which one you would like to pick or look at? Which one? 5. Okay. So let's look at 5. Was 5 the one that you had difficulties with?
Oh no, I had some weird wrapping difficulties with 1, but that's
With 1? Use the graph. So the question is on the graph of problem 1?
Yeah.
So use the graph of the function to estimate the slope of the tangent line at P. So they are equidistant. So when you graph the function, does it appear to be quadratic?
I honestly just did it by hand, so I probably
Okay, so we can look at the graph. So let's look at so 5 you said? Yes? Are we doing 5?
Yeah.
Okay. So in 5 we have 2 and lasting 0.5 seconds, 0.1. Okay. So T. So it's to 2.
Yes.
So 2 lasting 0.01. 0.05 and 0.1 and 2.5. Good. So I put those numbers in ascending order. So we are told to find the average velocity for the time period beginning with t and lasting, so between 2 and 2.01, between 2 and 2.05, between 2 and 2.1, and between 2 and 2.5. So in order to find the average velocity, I will create a function. So we are given y equals 40t minus 16t squared. And we are given the point. So our point Q in this case is 2 comma. I have to determine that. 40 times 2. So let's determine f of 2. F of y, or y is the same thing, f of t. So f of 2 will be 80 minus 16 times 4. So 80 minus 16 times 4 is 48. So what do I get? Is it 32?
Yes.
Perfect. So 32. So I have the point. Now, in view of what we covered so far, do you still think we have to do problem 5? I mean, we started it, so let's finish it. Okay, so I will create a function. Yes, please.
Is 16 times 4 64?
Yes, and I wrote 48. Thank you very much. Thank you. Good. So I have f of t minus f of 2 divided by t minus 2. F of t, 40t minus 16t squared minus 16 divided by t minus 2. We're going to do it in 2 ways. One way would be with a graphing calculator. Let's do just that. I brought it up. So in y equals, let's put this function in, which is 40 times x minus, like we did last time, but I wanted to show at least one more example so you know how to create that function, and minus 16, close the parenthesis, divide, don't forget to put in parentheses x minus 2. So I created a function that represents the slope of the secant line between 2 and the next point, and 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 2 and the next point. So I'm going to put in now these values. When I plug in 2.01 for t, I will get the slope between 2 and 2.01. The slope of the secant line between this point and this point, with this t and with this t. When I plug in 2.05 in here, I will get this slope. When I plug in 2.1 in here, I will get this slope, and when I plug in 2.5 in here, I will get this slope. Are we okay with this? Why am I doing this? Because I don't want to do it by hand. If you want to do it by hand, you can do it by hand. I just refuse to do that. Okay, so when I plug in, what would happen if I plug in 2? What do you think? I want to plug in 2. What will I get? Of course, it has to be an error. It won't allow me to plug in anything. Please allow me to plug in. Really, it goes back to, I thought I had it saved into the ask mode. I'm sorry about that. No, it goes back. So when I plug in 2, of course I have to get error, because I cannot divide by 2 minus 2, which is 0. So I will plug in 2.01. I will plug in 2.05. I will plug in 2.1. And I will plug in 2.5. And here's what I get. So for 2.5, negative 32. For the next one, negative 25.6. The next one, negative 24.8. Next one, negative 24.16. And if I want to determine, I'm assuming at some point in time they will ask us the instantaneous velocity at that point. I will plug in 2.000000001, and I will get negative 24. And that will be my guess. That will be my guess for the slope of the tangent line to the graph at that point, which is 2, 16. And that's what it says. Estimate the instantaneous velocity when t equals 2. I highly recommend do this, create the function specifically for 2, 16, right? So put f of 2 here, which is 16, and the x value here, of course. This is the slope of the secant line. And then just plug in the numbers you are given instead of doing it by hand 4 times. You'll get the same thing. But it's easier if you create that function. Perfect. Other questions for me? Other questions for me? I know we did the same thing like 10 times already. So do we have other questions from these problems? And now you can finish that homework. You can do this at 7 and 9, I think, because we looked at the generic situation as well. Okay, so now I would like to finish up our handout. The slope of the tangent line to the graph of a function at the point. The instantaneous velocity. And again, we do not know this yet, but I'm telling you now, all these three things mean the same thing. Same. All these three concepts mean the same thing. If we talk about the tangent, the slope of the tangent line to a graph, or we talk about the instantaneous velocity, or we talk about the derivative of a function at the point, they're all the same concept. They're all determined in the same way. And we'll talk about the derivative when time comes. So explain your own words how to estimate the slope of a tangent line to the graph of a function given explicitly. We are given the function f of x equals, that's what it means explicitly, or through experimental data. So what will you say? How do I estimate the slope of the tangent line?
Find the slope of the secant curves.
And then make that little difference, which is normally called h, make it approach 0. And that's how I determine the slope of the tangent line. Very good. So start with a point. You can start with a generic point, f of x comma q x comma f of x, and then determine the closest one that we normally denote by x plus h comma f of x plus h, like we just did. Yes. How to estimate the instantaneous velocity, you already answered. It's the same idea. I have to make h approaching 0. Good. So I think that's completed now. And I do have a handout that I created for you. I just have to grab it from here. And I wanted to solve this problem, the one that you picked, problem 5, also algebraically, because that is really what we are going to do now in a few seconds. Okay. So we have this. This is the slope of the secant line, correct? Okay. So the next step would be to look at the numerator and say, well, it's first of all, it's not arranged in descending order. And then I will have to do this. Then you will say, what? You will say, oh, you can factor out -4. And I will do this. Oh, actually, even -8. That's even better. 5 and 2. And then you will say, what? You can factor the top. Okay. How will I factor the top? Can anyone give us the factored form of the numerator? I can give you one factor, and you'll give me the other one. But then -2 times 3 will not be 2. 2t. If it's positive, then -2 times +1 will not be +2. Good. So now let's check. Let's make it sure, clear. So 2t times t is 2t squared. minus 4t and minus t is definitely negative 5t, and negative 2 times negative 1 is 2. Okay, here's a question for you. How did I know that there must be a t minus 2 up there? Nope. Nope.
Oh, because of the denominator.
Because of the denominator. Yes. Yes. So if you plug in 2 in the numerator and 2 in the denominator, you will get 0 over 0. Which means that there is a factor, the same common factor, top and bottom. And since there is only one factor in the denominator, I knew that the other one has to be at the top. I'm telling you this because this is going to be a theme for the next couple of sections, even more. So I knew that this must be the case. And now I can simplify it. So the simplified form is negative 8, 2t minus 1. Now I would like you to plug in here. What do you think I'm going to ask you to plug in this expression? And what will you get? Without even performing any operation. Negative 24. Why? Because of the same reason. When we plugged in this expression, 1, we got negative 5. That's why I always create the function, and I recommend you create the function. So remember, we determined negative 5 before we determined this expression. And then I said, okay, let's plug in 1 here and see what we get. And we did get negative 5. So now, we did not think of doing this. The problem wasn't asking us to do this. The problem was asking us to numerically identify a good approximation of the slope at 2, of the tangent line at 2. But since I have this created, this function created, I simplified it as much as I could. And what does this represent? This is the expression that will give us the slope of the tangent line to the graph of this function at any point you can think of, including 2. So 2 times 2 is 4. 4 minus 1 is 3. 3 times negative 8. And this is what we determine numerically. So numerically, I plug in the calculator and I punch in 2.00001. But there is a more elegant way. Once I create the function that gives the slope of the secant line and I simplify it fully, then I can plug in any number I want, because this expression will give us the slope of the tangent line at any point. So coming back now to the handout that I just gave you. I made one for me too. Maybe. It must be here. Because I made new copies. Yes, here it is. Okay. So finally we get to what it's called the limit of a function. So let's start. I did introduce the notation for the limit. We have 3 different possibilities. We have the limit from either side. We have a limit from the left. And we also have a limit from the right. So let me write what this means, first of all. So there are 3 notations. Limit as x approaches a from f of x is the limit is a number. If it's not a number, so this must be a number, not infinity. Infinity is not a number. So what does this mean? It means that as x gets closer and closer to a, the function values get closer and closer to this, whatever it is. So let me give you an example. So let's say limit as x approaches 1 from 2x plus 1 is 2 times 1 plus 1 is 3. And one more time, what this means is, as x gets closer and closer to 1 from either side, this function values get closer and closer to 3. So if I graph this function, when x is 0, y is 1. When y is 0, x is negative 1/2. So this is the graph of f of x equals 2x plus 1. As x, all my markers are under here. So here is 1, and here is 3. So x equals 1, L equals 3. As x gets closer and closer to either side of 1, the function values get closer and closer to 3. So this is the limit from either side of 1. We also have the notation limit of 2x plus 1. I'm giving you an example. As x approaches 1 from the right, meaning we are only interested in what happens to the values of the function as x approaches 1 from the right only. We also have the notation limit as x approaches 1 from the left of 2x plus 1, which means we are only interested in as x approaches 1 from the left, where do the function values go? So this is from either side. This is from the right, and this is from the left. So coming back to our handout. So this is the formal definition. This is exactly what I just explained. So you can write in here if you'd like, please. The left-hand limit means f of x gets closer and closer to L as x approaches A from the left of A. F of x gets closer and closer to L as x approaches A from the left of A. Now, I think that since we had a couple of examples of this, you will be able to fill in this table without me, correct? But I would like someone to give me the slope of the secant line, the generic form that you will, hopefully, I'm hoping that you will plug in the calculator and not try to do it by hand, step by step.